Picture a world where microscopic machines, no larger than a grain of sand, silently work to rid our planet of pollution. They glide through waterways, breaking down contaminants, or infiltrate soil to neutralize harmful toxins. This isn't science fiction, it's the promise of nanotechnology. As we face growing environmental challenges, nanobots could emerge as an innovative, game-changing solution for cleaning up our planet. Nanobots are minuscule robots, often just a few nanometers in size, designed to carry out precise tasks at a molecular level. Though invisible to the naked eye, they can be programmed to detect, capture, and neutralize pollutants in water, soil, and even the air. These microscopic cleaners are equipped with sensors, tiny propulsion mechanisms, and specialized materials that allow them to break down hazardous substances into harmless byproducts. For instance, nanobots designed for oil spill cleanup could identify oil molecules, disassemble them at a molecular level, and convert them into environmentally safe compounds. Unlike traditional methods that use harsh chemicals or mechanical cleanup, nanobots could perform the task more efficiently while minimizing collateral damage to marine life. Water pollution remains a critical issue, with microplastics, heavy metals, and industrial waste threatening freshwater sources. Current filtration and purification methods are expensive and often inefficient. Enter nanobots. These tiny machines could actively seek out contaminants, trap them, and either break them down or transport them for safe disposal. Scientists are currently developing nanobots capable of targeting microplastics. These bots use specialized materials to bind to microplastic particles, effectively removing them from water sources. With further advancements, nanobots could help provide cleaner drinking water on a global scale, benefiting millions of people. Agricultural and industrial activities have left many regions with contaminated soil, making it difficult to grow crops or sustain healthy ecosystems. Traditional soil cleanup efforts involve excavation, chemical treatments, or long-term natural processes, all of which can be costly and time-consuming. Nanobots offer a groundbreaking alternative. By infiltrating contaminated soil, these bots could neutralize harmful pesticides, heavy metals, and other toxins at a molecular level. Some experimental models can even repair soil structure, restoring its ability to retain water and nutrients. With nanobot intervention, we could see faster and more effective soil restoration methods that don't disrupt surrounding ecosystems. While environmental cleanup is a primary focus, nanobots have potential applications beyond pollution control. Some research suggests that nanobots could be used to capture carbon dioxide from the atmosphere, reducing greenhouse gas levels and slowing climate change. In marine environments, tiny robotic cleaners could remove harmful plastics and pollutants, helping restore ecosystems vital to biodiversity. Nanobots could also be deployed in farming to detect soil health problems, deliver nutrients at a microscopic level, and even protect crops from pests without the need for chemical pesticides. Despite their promise, nanobots also pose challenges. One of the primary concerns is their control and life cycle. How do we ensure that these microscopic robots deactivate after completing their tasks? Scientists are exploring biodegradable nanobots that naturally dissolve after use, preventing unintended accumulation in the environment. Cost is another factor. While nanotechnology has advanced significantly, producing and deploying these bots on a large scale remains expensive. However, as research continues, production costs are expected to drop, making nanobots a more viable solution. Ethically, the emergence of nanobots raises questions about accountability. If industries know that nanobots can clean up pollution, will they be less motivated to adopt sustainable practices? Policymakers and environmental organizations must ensure that this technology complements, not replaces, existing efforts to reduce pollution at its source. The potential of nanobots in environmental restoration is undeniable. These microscopic machines could be the key to addressing some of the most persistent pollution problems, from oil spills to toxic waste and contaminated water. While there are hurdles to overcome, ongoing research and responsible deployment could make nanobots a vital tool in our fight for a cleaner, healthier planet. We are on the brink of a new era in environmental science. With further development, nanobot technology may soon transition from laboratories to real-world applications, transforming how we approach environmental conservation. The future is small, but its impact could be enormous. Thanks for watching, and don't forget to like and subscribe for more deep dives into the world of AI and robotics.